So this example is going to be a little bit different from previous ones that we've seen. And that is because during the solution, we're going to be using the quadratic formula. Now let's get started with this example. So this question asks, with an alarm clock is thrown straight down off a bunk bed at 12 meters per second. If the clock is released at a height of 2.1 meters, how long does it take to hit the floor? So what we're visualizing here, let's draw some kind of bunk bed. Let me draw this bigger. Some kind of bunk bed. And I'm not an artist by any means, so we're just gonna have to bear with me. Got some kind of little bunk bed, and we're standing up here. We're actually going to be a little bit bigger. We're going to be lying down in this bunk bed, and our alarm clock goes off, and we are going to be throwing it. Here, how can I draw this? We're going to have a long arm, a long arm that is holding an alarm clock. There's our little alarm clock, and we are going to be throwing it straight down. At a speed of 12 meters per second. And it is going to eventually hit the ground. And one more piece of information that we have is that the clock is released at a height of 2.1 meters. So from the clock to the ground, we have 2.1 meters. All right. And we want to know at what time the clock actually hits the ground. All right, so now that we have kind of, and yes, I once again apologize for my strange drawing, but it's very useful to be able to visualize what you're thinking, what the question's asking. So whether you're good at drawing or not, always do some kind of little sketch to familiarize yourself with what the question's actually asking. So that's what we've done over here. Now we can move on to solving the problem. So step one is same as any other question, to organize our variables. So let's look at the question and see what values were given. So alarm clock is thrown straight down at 12 meters per second. So we are given an initial velocity, and it is 12 meters per second, but we have a direction, and that is down. So towards the ground, it's going to be negative 12 meters per second. Moving on, next piece of information that we have is that the clock is released at a height of 2.1 meters. How long does it take to hit the floor? So the question is asking us, after throwing the alarm clock, 2.1 meters later, what amount of time has passed? So we are given a change in displacement there. That is 2.1 meters. During the time that we're analyzing the movement of this clock, it will be moving negative 2.1 meters because it's starting at this line that we'll call 0, and it's moving. I'm just going to draw it in line with this tick. This is our 0, and our distance traveled, it's going to be negative 2.1 meters. All right. So that's two variables, and then a third one Similar to many other questions we've done, the third value is not explicitly given in our question, and that is an acceleration. Again, this is a value that you need to memorize as long as we are on Earth. The acceleration due to gravity is negative 9.81 meters per second squared. And then our fourth variable, which is going to be our unknown, is how long does it take to hit the floor? So how long, that is units of time. So we have our unknown variable, that's time. I forgot to put the number 1 on step 1. I apologize. Moving on to step 2 now. Step 2 is to choose an equation. And how do we pick an equation? We are going to look at the variables we're given and our unknown. We have 4 variables: v1, delta d, acceleration, and time. We're going to bring those variables over to our chart here, and we're going to find which equation makes use of all of the variables that we have. So v1, delta d, acceleration, and time. That's equation 2. I've numbered it equation 2. Your textbook, your teacher might have different numbers associated with the equations, so it's important to look at the equation itself. But given that these are the variables that we have, we will be using this equation here. So I've called it equation 2. So given that we have the v1, acceleration, delta d, and time, that tells us we're going to use equation number 2. And that brings us now to step number 3. We're going to plug our variables into our equation. So plug in variables. All right, so I'm going to start off by rewriting our equation. Delta d is equal to v1 times t plus 1/2 a t squared. All right, now let's look back at our variables and start plugging them in to this equation. So our delta d is going to be negative 2.1 meters. Moving on to our v1, we have a v1 of negative 12 meters per second. So negative 12 meters per second. And we have the time, and what is our time? Well, that's our unknown. So we're just going to write a t. Plus 1/2, and our acceleration. Let's look at what we have for our acceleration. It's negative 9.81 meters per second squared. Negative 9.81 meters per second squared. And then finally, our last value is squared. That is once again t. Let's just simplify this a little bit. Make it a little more clear to read. I'm going to keep t a different color so we can keep track of our unknown. And then here we're going to multiply these two together just to simplify. This will actually be a negative 4.905 t squared. Now from this point, in previous examples, the next step would have been to rearrange the equation to isolate for our unknown variable. But you can see something different about this problem is that we have our unknown variable t, but it shows up in two spots in our equation. One with a coefficient and one with a coefficient and an exponent. So the fact is, since we have an exponent on our 1t value, there's no way for us to isolate t in our equation. So this is where a different step is going to come in. So in this problem, step 4 is going to be quadratic formula. Quadratic formula. Now you should remember this from your math class, but if not, I will rewrite it out here for you. But the reason is because our unknown, which is t, cannot be isolated, because of that, we must use the quadratic formula. So since our unknown cannot be isolated, use the quadratic formula. And we're gonna put an exclamation mark because we're excited about this. Okay, so here's our quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac. Let me write that without the brackets. It's a little cleaner. Minus 4ac all over 2a. And that is when you have an equation in the form ax squared plus bx plus c equal to 0. So let's take a look at our equation back here. We're going to need to rearrange this into the form ax squared plus bx plus c equals 0. So I'm going to write that step out here. So rearrange to the form ax squared plus bx plus c equals 0. We need this equation form to use the quadratic formula. So let's take this equation over here, and we have our t squared, so this is going to be our a, so a t squared, this is going to be our b times t, and then this will be our value for the constant c. But we need to rearrange all this onto one side of the equal sign and put a 0 on the other. So what I am going to do is bring this to the other side, bring this to the other side. So this will become a positive, this will become a positive, this will stay a negative, and we'll have this big equation on this side and then a 0. So let me write that out now. This is our equation 4.50 or 4.905 times t squared plus 12 times t minus 2.1 is equal to 0. So you can see that this equation is just a rearranged form of this equation in the form that we need for the quadratic formula. And it's also important to note that whereas in this equation we've got x, here in our problem we're just using t, This doesn't affect the quadratic formula, it's simply a different variable. So here's our quadratic formula. T is equal to negative b plus or minus b squared minus 4ac all over 2a. Now let's plug in these variables. So it's equal to negative b. Our b is 12, so b is 12. So it's going to be negative 12 plus or minus. And our b is 12, so 12 squared, minus 4. Our value for a, looking at this form here, our value for a is 4.905. And then for c, negative 2.1. That is all over 2 times a. Again, our value for a, 4.905. 4.905. All right, so we have all our numbers plugged into the quadratic equation. Now it's just a matter of typing this into the calculator. So I encourage you to solve this along with me. We have 12 squared, 144. You know what, I'm going to write this all in one step actually. So all this that's under the square root symbol, I'm going to type it all into the calculator at once and get a value of 185.202. And you'll know that 12 squared is 144, and this value here is going to be added because we have a double negative and a negative. So we're going to have 4 times 4.905 times the negative 2.1. And when we subtract a negative value, it's going to become a plus. So that's why we have a positive number under the square root. That is over 9.81. That's just multiplying the 2 times the 4.05. And then if we type in the square root into our calculator, it'll give us a value of 13.61. And this is the part where our answer splits into 2 options. So we got 2 different possibilities because we have the plus or minus here. So one answer is going to be negative 12 plus 13.61 over 9.81. And our other answer will be negative 12 minus 13.61 over 9.81. And then solving for each of these, we're going to have to solve them both. So 1.61 over 9.81 is equal to 0.164 seconds. And that is the answer for t. So t is equal to 0.164 seconds. And with our other answer, we get negative 25.61 over 9.81. And that gives us an answer of t being equal to negative 2.61 seconds. So it looks like we have 2 answers here for t. Only one of them is real. Only one of them can actually be an answer. And Well, we're looking at t is a unit of time, right? And we're wanting to find, back to the question here, how long does it take for the alarm clock to hit the floor? So looking at these two answers, we know, well, a negative time is not possible. We can't go backwards in time. So this answer here, we're going to cross out. It is not the answer that we are going to look at, because negative time is not real. So the answer that we are going to accept is on this side over here. T equals 0.164 seconds. And if you remember in the original question, looking at our significant digits, we are given two significant digits. So we want to write our final answer in two significant digits. So 0.16 seconds. And that is our final answer. Now, just to reiterate what this means, that means from the time that the alarm clock is released at 12 meters per second. After it is released, it will hit the ground, which is 2.1 meters below. It'll hit the ground after 0. It'll hit the ground. We have our answer for t now. Time is equal to, it'll hit the ground at t equals 0.16 seconds. So we can write that at the bottom as part of our answer. Therefore, it takes 0.16 seconds for the alarm clock to hit the floor. And that is our final answer.